Okay, so today we're going to be doing finding congruence in overlapping triangles. And so what we're looking for here is to find some overlap in either a side or an angle. And so kind of the toughest part about this is visualizing what we have. So what kind of helps is trying to use like highlighting or color coding to see what you're trying to prove equal. So with this problem right here, I want to prove that XZW, so XZW is this triangle right here, and prove that it's equal to WYX, that triangle right there. And so, again, my first step is my given statement. Oops. My given statement already has two things equal, so I just have to find one more thing. And so with my second step, again, I've used all my written given statements. I now look at the picture to find a reflexive property or bow ties. So what I need to see here is when I have overlapping triangles is to find the side or angle that is shared between both triangles. And so if I look at this one right here, I think you can kind of tell that this right here is where the yellow and the purple are overlapping. So I can say that WX is equal to WX by the reflexive property. Then I know my triangles are equal to each other, so XZW is equal to triangle WYX. And so this, sometimes when they're together, it's hard to see where the angles and where the sides are because it kind of looks like a hot mess right now. And so what you can do is I'm going to actually go ahead and draw these so that they are pulled apart from each other. So I'm going to, underneath the picture, be able to draw that. There's my purple triangle. And then, that was a terrible picture. And then there's my yellow triangle. So if I can label these points, so I've got W, X, Z, and this one is W, X, Y. And so just by marking on one of the pictures what's equal, then I can see how they're congruent. So I've got angle, so I'm going to mark it on my purple triangle. I know that angle, let's see, ZXW, oops, blue. That angle is equal, and I know that ZWX is equal, ZWX, and then I've got WX is equal to WX, so that side. And so just by looking at one of the triangles and marking on one of the triangles, I should be able to see that that is that's angle side angle, because I've got two angles, and the side that's in between them is congruent. With the second one, again, same thing. First thing that I want to do is write down my given statement. The second thing that I want to do is, let's see, I've got BD is perpendicular to CD, so I've got a right angle here and a right angle here. Oops. So with 2, I can say that angle ACD is equal to angle BDC by definition of perpendicular. Now with my third step then, I have in my given statement that BCD, so BCD, this angle right here, is equal to ADC, which is this angle right there. And so again, trying to look for the overlap, so if this is my blue triangle here, and this is my yellow triangle here, you should be able to see that same overlap where the blue and the yellow are mixing together, making that whatever color that is. So I've got CD is equal to CD by reflexive property. So again, to see how they're equal to each other, what I can do is I can redraw the pictures. So with this one, this is my purple triangle, and this is A, C, D. Got my right angle, got my angle here, and then I've got my side right here, the side that's in between. And so this is going to be another angle side angle. So triangle ADC is equal to triangle BCD. And that's my ASA. Flip over to the back. One more. This one's just going to be a little bit different because I have something, I have a different overlap than the other two. So I know that angle T is equal to angle R, and I know that VR and QT are equal to each other. So I'm going to actually trace these triangles now. These are the triangles that I'm trying to get to be equal to each other. So I've got a purple and a yellow triangle. So again, I've got my VR and QT are equal to each other. So VR and QT. Just make sure that we understand that that's the entire length here. So this whole thing is TQ, or QT, and then this whole thing right here is VR. So those whole sides are equal to each other. So when I mark these guys equal, it's the whole thing, not just TS and SR. And so with my overlap here, I don't have an entire side. This PQ right here has some overlap, but that's not an entire side of either of the triangles. It is of the purple, but it's not an entire side of the yellow. So this is one where I'm actually, my overlap is this angle up top. That angle P right there is in both of my triangles. So like if I were to redraw it, there's my purple triangle. And then if I redrew other one, there's the other triangle. So this is TQP, and this other one is VPR. VPR. And so I've got angle, side, and then there's an angle over here. Same thing with this one. I have an angle here, and an angle here, and then the side here. And so again, when I'm looking at those to, my second step, I go angle P is equal to angle P by reflexive property. So I can say then that my triangle PVR is equal to triangle PQT. And this one, again, just by looking at one of the triangles, look at that purple triangle. The side's not between the angles. And so I know, two angle marks there. So I know since the side isn't between the angle, it's going to be angle, angle, side. Then the last one that we have here, so this is, these proofs are pretty difficult. So this would be a type of proof that would be extra credit on the test. So there are some times where I'll have to prove one pair of triangles are congruent to prove that some sort of other triangles are congruent to each other. So with this problem right here, I want to prove that QET and QEU are equal to each other, the triangles. So I want to prove that this triangle QET is equal to this triangle QEU. And so again, where I'm going to start at is with my given statement. So I've got angles 3 and 4 equal to each other, which is already marked on the picture. I don't have any other given information other than angles 1 and 2, which aren't part of that triangle, to use. And so what I can do is I can say, by looking at my picture, I can say that QE is equal to QE by the reflexive property. But just looking at that, that only gives me two things. I've got an angle and a side. I can't say anything else. Even though it looks like it's a 90-degree angle, I can't say that it's perpendicular. And so I'm just kind of stuck there. So what I can do is, to prove that these triangles are equal, I can look for another pair of triangles that would be equal to each other, and then use the corresponding parts of the CPCT to be able to help me prove that the other triangles are equal. So if I look at these big triangles, QBT and QBU, I've got two angles, and then I've got an overlap in that side QB. So with my third step, I can say that QB is equal to QB by reflexive property. So I've got two angles, and now I've got one big side, and so that gives me my three things to prove that these big triangles are equal to each other. So my fourth step is going to be that triangle QET is equal to triangle QEU. Oopsie, nope, that's not it. It's wrong triangles. Triangle QBT is equal to triangle QBU. Sorry, my fault. And I can say that because of angle side angle. Because I've got two angles and the side in between to prove that the purple and that yellow triangle are equal to each other. And so where this helps me at is, so I know that the big triangles on the top and the bottom are equal to each other, so I can use a corresponding part that is the same in the big triangles than the small triangles that I had highlighted first. And so what I can do is QT and QU are two sides that are in both the big triangle on the top and the bottom and the little triangle that I'm trying to prove are equal to each other. So I've got my side, QE is equal to QE. I've got my angles 3 and 4 that are equal to each other. And then I can be able to say that QT is equal to QU. So QT is equal to QU because they are corresponding parts of the congruent triangles, of the big triangles that I just showed are equal to each other. Now I have three different things that are equal to each other. And so with my sixth step, I can say that what I wanted to say, triangle QET is equal to triangle QEU. And that is by, I've got two sides and an angle that is between, so that would be side angle side by SAS.